All right, thanks for having me. This is the first time I've gotten an opportunity to speak at this summit. You can see the name of the talk there. It's a little bit about myself. The genesis of this talk comes out of some of that adversary emulation work and around APT actors. And there's some other things that we've done as well, but this one was kind of interesting. So I'm going to start by taking you back in time. We're going to go back to a sunny day in October 2020, and you may have read a report around that Microsoft and Mandiant had both identified a fairly unique target, now known as Solorigate, right, where we had this supply chain attack that was somewhat novel. We had some on-premise attack going on. We had a pivot using ADFS, Active Directory Federation Services, that in turn got into Active Directory, Azure Active Directory. The MFA tokens that you would normally use could kind of be driven around. And while the term Golden SAML had been introduced about 3 or 4 years ago by CyberArk, Golden SAML started kind of taking root. So fast forward a couple months, I was at my previous employer, and we were starting off building an APT scenario. I was my role with this Blue Team CTF. And I thought, wouldn't it be fun, and I use that term loosely, to kind of do the rip from the headlines kind of thing and build an emulation around that. So as I'm thinking about this, I'm like, okay, I've done a lot of this stuff with on-premise before. We've done some other things. Imagine all of the wonderful telemetry I'm going to have from a cloud-based attack. Wouldn't that be wonderful? So I sat down, I worked through this. We actually did a little bit of the supply chain side on the one side, didn't get as much mileage out of that as I thought I would. I had the on-premise attack, I had Sysmon in there, I had Zeek, I had some insider threat detection solutions in there. I got some really good logging coming from that end. I was feeling pretty good. Spend a lot of time working through trying to figure out how I'm going to go ahead and do this ADFS compromise with the pivot and grab the SAML token and do the pivot to the cloud. Managed to get all that stuff kind of figured out. I get up to the cloud, and of course, that's the last part of the attack. So I'm like, okay, I'm flying at this point. I got deadlines, and I kind of chop it out and do the basics that I need to do for my CTF, and I'm feeling pretty good. Sit down, start looking through my data, because when you build a CTF, one of the things you want to do is you want to go ahead and start going, okay, what kind of data do I have? What kinds of questions do I want to ask? And I started going through, and I felt pretty good about my on-prem data. And I started looking at my cloud data, and I started going, this isn't good. Where's my cloud data? So I kind of look like this guy. I'm busy pointing in all different directions. I was concerned, did I misconfigure my Splunk, right? Was I not getting the right feeds? I then started getting a little paranoid and going, okay, is there something that Splunk isn't getting that maybe Sentinel would be? So after our CTF launched, I kind of went back, I reran my emulation in Sentinel, and I was relieved, I guess for lack of a better term, to see that I saw kind of the same stuff in Sentinel. I'm like, okay, so it's not me. So I had the opportunity to take the 509 class. Dave Cowan was the instructor for that class. He was one of the co-authors. We got to the day around Azure, and he got a lot of questions from me. He was very patient and answered those questions. And I kind of got to the point where I was like, okay, I think I just kind of understand that this is what you get and what you don't get and everything else. So I was going to kind of put it away. And then I went and did a talk around how to build an adversary emulation. And I talked kind of lessons learned, and I talked briefly about this specific thing. And at the end of the emulation talk, I got questions about emulation, but I got a lot of questions about ADFS and this attack. And I was kind of like, okay, I kind of thought this was a little bit of older news, but clearly there's some interest in understanding what this attack is, the visibility associated with it. So I kind of decided, you know what, I'm going to kind of stay on this thing and kind of keep pushing and seeing what I can find and understand that as things evolve over time. So I moved to a new role. I'm at Google, as you saw. I revisited this attack with Chronicle. I even dusted off my old copy of Splunk. I dusted off some new connectors, and I ran it there as well. And I started looking at it, and there was some differences, but for the most part, it was pretty much the same. And that's maybe good in some ways and a little scary in other ways. So where does this leave us? The Graph API and all of the endpoints that are associated with O365 and Azure Active Directory are not going away, clearly, right? There's a huge infrastructure there. It's very, very powerful. It's very, very rich. It interconnects Calendar, Contacts, Exchange, SharePoint, OneNote, Azure, all these Active Directory, I should say, all together, right? So clearly that's not going away. Microsoft is trying very, very hard to move users from ADFS to Azure Active Directory all inclusive. There's actually a YouTube video where you can see them kind of talking about how you can build these migrations and do all this. The reality though is that ADFS is not going anywhere anytime soon, right? Because there's a heck of a lot of legacy applications. It's a heavy lift. It's not something that's very, very easy. So where does that leave us? Okay. The fidelity that Azure has is good for key changes. This is a little bit of the TLDR here, okay? But if you're a defender who spent any time in on-premise environments where you have the Windows event logs, the sysmon logs, right? The rich data that you're used to in an on-premise environment, that's not necessarily the stuff that you're gonna see in an Azure or M365 logging. And that's something that we have to kind of come to grips with, understand what we have, understand maybe what we don't have, and where to work through. And that's kind of the thrust of the talk today, okay? Now, to do this, I went ahead and built my emulation. We're going to be talking about it within the context of the Golden SAML attack. There are things here that are maybe, maybe you're sitting there going, well, I don't really have ADFS in any of the environments I have to deal with, so I don't have to worry about this. Hopefully there's things inside of this that are nuggets around the logging that's available to you that you can apply to your regular day-to-day lives if you have an Azure or M365 environment here. So hopefully there's nuggets here, but we're using the ADFS Golden SAML as kind of the case study to wrap around this. Okay. So when I initially built this, I did Server 2019. I moved it up to Server 2022, Active Directory running ADFS. The reason I did that was just to kind of prove out that there isn't anything unique in terms of technical countermeasures or anything else with the newer version of it versus the older version. At scale, obviously, this would be multiple servers. I have my budget. I'm going to do it on one box with ADFS and AD running on top of each other. Obviously, if I'm running this in a large organization, I'm going to have multiple federation servers, multiple Active Directory servers. Okay. I went through, followed Microsoft's installation instructions. I had to go to some other third-party sites to kind of figure out how to get my ADFS working. It's not exceptionally easy. That's probably a separate talk, but we're not going to cover that part today. And I built my system with my users and my different logs that's coming in there. Azure Active Directory Connect is the preferred way to handle federation between an Active Directory in ADFS up to Azure AD. And I'm kind of saying up to because I'm thinking of it going from an on-premise into a cloud. Okay, so that's the preferred way of doing it. You create your users in AD, it gets replicated up into Azure AD, and then it's obviously available there. So to kind of get off a dime with all of these things, Roberto Rodriguez, who's actually now at Microsoft, had written this Simulan project, and it was incredibly helpful. It's actually out there on GitHub if you want to check it out. It was incredibly helpful to kind of work with the initial key attack and understand kind of how these different pieces work. It was kind of a good springboard for me to go ahead and kind of get my PowerShell chops underneath me for making calls to the Graph API and then be able to kind of go off on my way with that. But it was incredibly helpful as part of that. So it was a big thank you to him. All right. So what are some of the cloud logging that I have available to me when I start looking at O365 and Azure? I've got Azure AD sign-in audit logs. They're available to you. You can get those. You can see those. By the way, all these things you can see if you log directly into Azure AD or 365 as well. You've got Azure AD audit, which is the directory audits. Those are the other things that are happening within the environment, right? I create a client secret. I create an application. I make a permission change, right? Those are the kinds of things Azure AD audit has. O365 has a number of different kinds of log streams in it. There's Azure AD audit, which kind of sounds duplicative because it is a little bit, but that's okay. SharePoint audit, Exchange audit, general audit, and nothing better than a nice generic term, general, and then DLP. And then the last one is the Graph API alerts, which is more security alerts around Microsoft. The other thing that I'll call out is that when you are monitoring in a federated environment like this, there are some potential sources of noise that you're going to have to kind of cull through. That AD Connect that goes from on-prem into Azure is incredibly helpful, right? If I create a user down here, I see a user created up here. That's great. However, those synchronizations are happening on an ongoing basis, and there's a lot of logs that get created. So you kind of have to go through and get rid of the noisy pieces of it to get to the pieces that you want to see those things happening. There's also a compliance center app that I had running in the background. There was a thing called Data Insights. It was incredibly noisy. I think I literally got one good alert out of it during the time I had. For somebody who's maybe well-versed in it, you're sitting there going, you configured it wrong. That's entirely possible. But that's also kind of, how environments sometimes get set up too. So things you might have to go ahead and parse through. So we're going to walk through kind of a 5-step attack path here. The first step along the path, which we'll touch on, is the actual on-premise part where the attack happens. After that, everything else is going to move into the cloud. Okay. So this key theft piece of this, the key theft piece of this is where I'm getting the signing key that I'm able to go ahead and create my own SAML token. You can do this attack with a local admin with an ADFS service account, and that's what you need to be able to get access. The good news is the classic hunting, detections, investigations that many people are very comfortable with on an on-prem environment can all be handled here because this is part of your traditional on-prem environment. Okay. There's also a tremendous amount of good content already out there that I'm not going to belabor that. In fact, Roberto and Nestori writes the AAD internals toolkit and has done a tremendous amount of work on Azure Active Directory. Actually did a 45-minute presentation on Black Hat Europe in 2022 about writing and a deep dive into ADFS attacks. So I linked it here at the bottom. If you guys want to check out that, I would highly recommend it. If you want to understand more about defenses around an ADFS system, right? What I'm going to talk about is once the horse is out of the barn, what is the other things that happen? The other thing that is interesting, and this popped up late last year, early this year, is this newish, and that's why I said newer, graph API setting. And I put the quotes in here, not that I want to read it to you, and I bolded a couple of keywords, and it's a little bit of vendor speak, to be very, very frank, if you're reading it as I have it on the screen here. But basically what they're saying is, hey, you can go ahead and set your graph API such that every time you try to go into that thing, you're going to have to do your MFA authentication, right? And we highly recommend you doing this. And that last part is really kind of they're kind of talking around it, but basically, if you're not using a third-party MFA provider, turn this thing on. So that basically means if you're using ADFS, turn this on, right? So this is kind of their hedge against this Golden SAML attack to come through. Okay, so you could actually cut this thing off there. However, there's that whole functionality versus convenience thing of logging in with MFA every single time, and do people want to do that and all these kinds of things. But there is a setting there to kind of help mitigate this. For our purposes, obviously, as we were doing emulation, we don't want to mitigate this. We want the attack to happen so you can see all the other things that happen after that. Okay, so what are some things that I could potentially see in this first stage of the attack? Well, I executed a PowerShell script that was going ahead and grabbing the ADFS token signing certificate. It's a PFX file. I enumerated the domain admins and all of the other users in the domain. I'll get to that in a little bit, as well as getting their object GUIDs. Okay, and also my AD and on the configuration around the ADFS, just straight up PowerShell scripting. So obviously I could go ahead and try to monitor and look for those script block logs if I'm investigating this. But of course, something like a Covenant C2 masks that PowerShell visibility. So I don't necessarily get the script block logs. So that's something I have to take into account. File creations, file exfiltrations, I can start looking for some things like that. There is a local pipe that gets created, so sysmon event code 18 around connection to the Windows internal database, or a SQL call to there is something you could look for, things like WMI and LDAP being utilized. There's a DK, and it's cut off where my screen is here. It's the ADFS key read. There is a, what do I want to call it? There's a couple logs that generate off of that you could build a detection around that or look for instances of that. There's also that Azure ATP sensor. If you choose to deploy that, that'll flag on that. I'll show you what that looks like a little bit later here. So there's a couple ways to kind of mitigate this stage of the attack. Obviously, some of them are policy, some of them are investigatory. Okay, but once that PFX key is gone, it's gone. Right? Because everything else that we're going to talk about today does not require me to be on the on-premise environment, right? I can be sitting anywhere in the world and being able to attack, and you are wholly reliant upon what the logging availability in the cloud looks like, right? So, step 2. Once I have the signing key, I want to go ahead and basically build my own SAML token, and I want to go ahead and use that SAML token to craft an access token. So kind of a 2-step process. To create your own SAML key, you need 4 things, okay? We're using the AAD internals, by the way, to do this, but basically you need your tenant ID, okay? So there's a nice little script in that suite to be able to do that. There's an example as to how to go ahead and do that. I need to know the domain that I'm attacking, which kind of makes sense. But once I have that, I can go ahead and hit that. You will not see somebody querying for your tenant ID. There's nowhere in the graph that that's logged externally, right? I threw a PCAP. I threw Wireshark on my adversary server. I could see it hitting a server somewhere in Texas in Microsoft's enclave to look and query that and have it come back. But it's not something you would have visibility into, somebody knocking on the door and saying, hey, what's John's tenant ID? You have the object GUIDs. The object GUIDs I collected when I did my PowerShell script. That's the listing of the users. In this case, the domain admins. I can utilize this object GUID then to impersonate whoever I want to on that SAML token. You'll see that in a second. The certificate itself, great. And then the last piece is the issuer. You could just run and get ADFS properties at the server to be able to get that string. You're going to go ahead and do that. You build your SAML token and you craft an access token and you log in. The access token itself is a logged event because you are logging into your enclave, into that tenant. Now, in the farther back example, I've logged in as Tim. In the other example, I've logged in as Heather. Those are my two admins, okay? The only thing that was different between those SAML tokens was I swapped out their GUIDs, and now I'm as one, and now I'm the other, okay? So with those GUIDs, I can go ahead and log in as whoever those people are. You'll notice I logged into the Azure Active Directory PowerShell. That is a system-facing Azure app. That's a very, very common thing that's out there. We'll talk about that more in a second. And then in the security summary section, because I don't have that graph API setting on, it says successful login occurred, and don't know if you can read it from there, but it says literally MFA requirements satisfied by claim provided by external provider. You didn't see any MFA that I did, right? I've gotten in that because I got the signing token and I've gone through. It's just assuming, yeah, I'm good and I'm in, okay? So what could I look at? What could I be observing in this stage of the attack? Well, that Azure Active Directory PowerShell app is a system-facing app. All of these applications that are system level, and we'll talk about roles and permissions here in a bit, have published application IDs. So there's an application ID for this app. You might want to be looking for consistent or continual logins into that. There are good reasons to log into this initially. It's not something that you would necessarily expect people to log into as a normal course of business. So if you start seeing excessive logins to that app ID, that might be a big deal. Frequency, of course, is important. The Azure sign-in logs and the O365 sign-in logs will have an IP address in there. So that's helpful, right? It's, hey, they're logging in from this place or that place. The thing that is also important to know about O365 and Azure logs is there are other, in the audit stuff, there will be IP addresses in there, and you might say, oh, wow, 23, what's this interesting 23 address? It's a Microsoft address. It's like it's hitting like a SharePoint cluster in the background and saying, oh, I hit 23 and da-da-da-da-da. And it's not super helpful in that case. So, but the sign-in logs, the Azure sign-in, O365 sign-ins, IP addresses come in there. Those are probably good to keep in mind. And then the thing that you want to look for after this, after these access signing tokens into the Azure AD app is maybe what's that trailing activity look like? And that's what we'll talk about here next. Because once I'm in the environment, I want to go ahead and get access. Now, to get access into an environment, I have an access token, but the way you get access into Azure and do things is to go ahead and leverage a concept called an application. And there are applications in there. There are totally legitimate reasons to have applications in there. In fact, if you're collecting data into Splunk, if you're collecting data into Chronicle, if you're collecting data into other apps, you're going to create an app in Azure, set up your permissions so you can pull your log data through it. Okay, Zscaler I was looking at, I found Zscaler's instructions where they go ahead and configure an app to work with Azure with that. So there's lots of good reasons. That's not even getting into custom apps, right? So lots of good reasons to have an app. Now, if I'm an adversary, I could create my own app, which is a logged event, or I could potentially take advantage of an app that's already there and go ahead and leverage that. It's up to me. When you create an app, there's also a service principal that's created. If you create it in the UI, like you can see in the one corner there, both of those events happen and the service principal gets created. Those are both logged events. If I script this, do something like PowerShell, and I create my application, I have to do a separate execution to create my own service principal. I don't know if that's really a big deal to say, well, you know, we created the app here and 5 minutes later it created the service principal versus they both happen at the same time, because you need it either way, but it's something of interest. The next step is I'm going to go ahead and apply permissions. Okay, there's delegated permissions, application permissions. I'm just doing delegated permissions for this. Application permissions is probably a whole separate ball of wax. But when you create permissions, then there's all the different endpoints across Azure and M365. I have published GUIDs. I haven't published them, Microsoft published them. There are published GUIDs that are out there. In fact, the link at the bottom of the screen calls out what those are, and it gives you the opportunity to say, hey, there are probably some very, very interesting permissions that I want to be looking for and auditing and investigating to say, hey, have these specific ones been utilized? Okay. The user.read is not a super exciting one. The security events read write all, on the other hand, might be of interest. And that's the older one. There's a new security incidents one as well. The directory read write all, the directory access as user, right? So these different permissions are out there, but they're logged as GUIDs. You can be looking for those kinds of things. Then the last step of this is you have to go ahead and add administrative consent for the delegated permission rights. You don't have to do this for all of them, but there are the higher level ones, the juicier ones kind of need this delegated admin consent. They actually log out as specific names. So it actually has the words spelled out there. So depending if you like it, the words spelled out or you like the GUIDs, you can work with it either way. But anyhow, you're going to do that. So if you kind of look at these four-step process, right? I said the first two things are optional. And oh, by the way, the add permission, the create service principal can happen in either order. It doesn't really matter, but they all have to happen at some point. But the thing you're going to probably notice about this, and this is kind of where my angst about the logs that I don't have available to me is that these API calls are a post, a patch, and a post, okay? When I query to say, what are the applications that I have out there that I could piggyback off of? That's a get. That's not logged. When I start looking and querying the permissions that are associated with those existing apps, those are gets. I don't see those either. Okay, so all of the door knocking and all of the going ahead and recon and those other kinds of things, I'm not seeing in the application process. I'm just seeing the actual, I created an app, I added the permissions, I added the administrative consent. Those are all logged, but those gets that are happening in between and under the surface and those oops and gotchas, just, they're not there. They're not there for visibility. Okay. So what could I observe? I could observe application creation. That's certainly a possibility, but probably not something that's super useful, aside from maybe going back to my administrators and saying, who's creating all these apps? Or what apps are you guys actually using? And can we keep them to a minimum? And if there's a new one created, maybe we log this, but those kinds of things. The service principal is probably not going to be a great moving the needle kind of thing. I guess if you want to look at command line versus UI, maybe, but probably not. Better time spent in the permissions. Right? I could go ahead and look for specific GUIDs being assigned out. I could look for greedy permission grabs, right? Somebody went ahead and grabbed 13 of them, like that one that showed you where I had a big blob of GUIDs, right? That might be something interesting, right? In certain, depending on the app that's being utilized, they may not have to have all of those permissions, or somebody coming back over and over and grabbing more and more permissions. Delegated grants, words versus GUIDs, up to you. All right, so we've done that. We're going to establish some persistence. Why do I want to establish persistence? Because access tokens are only good for 60 to 90 minutes. Microsoft says, hey, we average out to 75. Well, 60 to 90, 75. Yeah, makes sense. So if you want to go ahead and gain consistent access, you could periodically what I'll call recharge your token. Now, Azure Active Directory PowerShell, as I said before, is a system exposed application. So if I keep logging back into that with a new access token every 60 to 90 minutes, because I'm doing some more things, or maybe if it happens just every week at a specific time or whatever, that might start getting suspicious. Instead, what I could do with my brand new app is I could go ahead and create a client secret inside of that app and utilize that. Now, again, good news, client secret is a logged event. I create a client secret, that's there, okay? But once I have that client secret, I could go ahead and do something like this. I recreate my SAML token, right? I encode my SAML token. I make sure that as I'm doing this, that the application that I just created or I'm piggybacking off of with my permissions is in my script. I use that secret that I just created, right? And then I go ahead and rinse and repeat, generate my new access token, and I'm in. And oh, by the way, since I stole all of those object GUIDs at the beginning of this, if I want to log in as Phil instead of logging in as Heather, I can go ahead and switch that object GUID, and now I'm in as Phil, okay? And that gets particularly deadly because if I'm going ahead and I'm doing something like, I want to go ahead in and I want to start going through email and I want to start going through file directories as that delegated user, if I'm logged in with that GUID, I'm in their directory, so to speak, in the me directory associated with them. If I'm logged in as this other person, I'm in the me directory associated with them, right? So you can kind of imagine in this kind of a scenario where, hey, this is looks like a legitimate app, because by the way, this is what it looks like in the login event. The things that are different are the things in red. The application now is Auth 365 rather than Azure Active Directory PowerShell. The app ID is the app ID that Microsoft assigned me for my custom app versus the system app that everybody is used to and is probably looking for, right? So now I start looking like normal kind of, hey, I'm just a custom app and I'm logged in as Phil doing something, or I'm logged in as Heather doing something, okay? All right, so what can I observe here? Probably want to start looking at client secrets. Client secrets often have to be deployed. Again, looking back at some of the ways that logging providers grab their data out of there, that is a way that they have to grab it. But might be something to look at. How many secrets are out there? What are the expirations on those? Are there anomalous, not anonymous, anomalous logins going into certain apps, right? Have we seen users, right? Has Phil ever logged into this app before, but now all of a sudden Phil's in the app, right? Those are the kinds of things to be thinking about. So understanding those login activities, kind of the classic stuff around that, but be things to think about in this specific environment. So that gets us to the last part, right? Which is the actions on objectives, right? Now I'm in, now I've got my persistence, I've got time to go ahead and do with what I want to. What are the kinds of things that I would do? All right, so I started writing this slide and I started with this very provocative statement that said no visibility into the get commands to API. And then I had to caveat that a little bit because I stopped and think, I'm like, I'm not going to deal in absolutes. Okay. But what is logged and what is not logged? So this is a sampling. This isn't obviously comprehensive across all of the different endpoints that Microsoft has in the graph. But what are things that are not logged? Give me a list of the users and their GUIDs and their email addresses and all those kinds of things that have been replicated. That's not logged. Tell me about the users with the global admin role or tenant admin role, or whatever you want to call it. Tell me which token I'm currently using. Tell me about the mailbox rules of this user. Tell me about the user contacts, calendars, license this user has. Tell me about the OneNote pages they have. Enumerate the folders and files that this person has in their directory, okay? None of those things generate an event log, okay? Now, if I go ahead and say, I want to read the mail messages, right, and give me 10 mail messages, right, it'll actually log the message ID in the event stream to say, hey, these 10 mail messages were provided back to whoever was asking for it. And similarly with OneNote, if I wanted to preview OneNote, you'll get a file access. It'll be like, projects.1, right? It won't necessarily which of those pages in there, but it'll say, hey, project.1 was accessed. Now, the tricky part with both of those is that if you think about normal kinds of behavior, those kinds of normal kind of behaviors are going to happen all the time. You know, you go in through the UI and you're starting working with it. Those things generate a lot of logs as well. So trying to separate those get a little bit tough. But that's kind of where the gets are inside of this space, which gets a little bit scary. Now, if I add a role to a user, the roles are going to go ahead and be logged. In fact, I screwed up. I had my little OPSEC break as I was doing this. I created a user named Phil. Had already given him the global admin role. I went back and redid it again. I got distracted, ran it again. I got a 400 error in my PowerShell script that I was running, but Azure dutifully logged it and said, hey, they tried to add global admin to Phil again, right? So those ads, those updates, right? Those get logged for sure, which is good. There's also constant updates as to new things coming in. So I ran this thing end to end pretty hard in April and had my logs, and I've kind of got a pretty good feel as to what's there every single time I run this thing and what's new. There was a new privileged identity management log that came in through the Azure AD log stream that's been brand new since April. It just kind of started popping up. Now, you still see it in the Office and the Azure AD audits as that add role, but they've kind of created a special one to go ahead and log this a couple minutes later after it happens. Not exactly sure why that was, because I haven't lost the fidelity from having it in those other spots, but it was nice to see that they're looking and going ahead and bubbling certain things up. So, a couple of things to observe here. Those roles that I talked about, much like system applications, have published GUIDs associated with those, right? So I could be like a reader, right? I could be an application reader, or I could be an application administrator, I could be a security administrator, or there's all these different roles that are there. Those roles all have known GUIDs. Looking for those roles. Look whose roles are being assigned to whom Okay, those can be very, very important things to be looking for. Not, like I said, there's minimal enumeration available here, so you really have to focus on those change events, those add events, if you will. All right. I talked a little bit about security alerts that are out there. That ADFS DKM key read came in through the Azure ATP data just by installing that sensor. I see that happens, that triggers through that Graph API alert. I turned on the email, I set up a mailbox rule, right? So the mailbox rule would log, obviously, to say add mailbox rule, but I was pleasantly surprised to see that Azure fired a specific Graph API alert to say, hey, there was suspicious email forwarding. Okay, this can be seen in their portal, in the security portal there, but it can be seen elsewhere as well. The one challenge I've seen with these security alerts is there's stuff that I've seen historically, and I stopped seeing them, and I see some other ones. So it's kind of like there's things that were there before, things that fell away. Which is kind of surprising. There's a lot of different activities that are logged. O365 does all of these kinds of things, right? So we're talking about the adds, the creates, the deletes, even the reads, downloads, anonymous share links, right? Those are very, very good. I recommend that from like a OneDrive perspective. Azure AD obviously does a subset of that because they're not as focused on the Office parts of this. And then the Graph API can do things like the security alerts. As an example, if I went ahead and had access to the specific API and the permissions, and I wanted to go ahead and mark one of those security alerts I showed you on the previous slide as a false positive, don't worry about it. I got it covered, right? That would generate a Graph API alert, but you could also get in there and monkey with those things. All right, so from a visibility perspective, if I could only choose one set of logs to work with, I'd choose the O365. The Azure AD sign-ins are pretty much duplicative there. The Azure Directory audits, the only difference was those PIMs. Otherwise, O365 covers it. The Graph API, honestly, if this was drawn to scale, that would be Pluto, and the big blue one would be the sun. Okay, so there's a little bit of a nuance there. But the other thing I'd also say is because these data, these feeds are kind of best effort and have some time associated with them that are a little bit nuanced. I've even had times when I've run this scenario where, let's say there was an Office 365 ad activity that I was expecting, and I didn't get it for whatever reason. They just dropped it somewhere along the way. I'd suggest logging both. So if somebody's doing a finding and you're saying, hey, what should I be logging? Log both. There's not a ton of logs associated with them, but grab them both. All right. So we're into the last slide or two. We, looking at things from an on-premise perspective, are used to CRUD, C-R-U-D, right? Create, read, update, delete. I kind of think of this as we kind of get duck, right? We get the deletes, we get the updates, we get the creates. Those are good, but that read piece is really missing. And so an adversary could do something similar to what we did here, where we created our own environment, right? We stand up our little E5 developer account, we test and we script. We have all sorts of support because there's a lot of great documentation around working with the Graph API. All of those hiccups, those stumbles, those recons that we do on-prem where it's just not quite working, but they leave behind little telltale signs that help us. Those things aren't there necessarily because those gets aren't there, right? If I make a mistake on my application of an update or a post, that's a different story, but I just don't have those other kinds of things. And because I don't have all of that other kind of stuff, once I get initial access, right, and I can start mining the data, right? There's a heck of a lot of stuff that can be happening there that I may not have any visibility to as an analyst until the file access happens, until the mail access happens. And at that point, is that the horse out of the barn again? And it probably is, which then makes the damage assessments difficult because we have to kind of assume full breach at that point. So I gave you some homework reading. I mentioned a couple of those. If you want to look at the initial Solorigate, the Microsoft one there, we got some nice Mandiant white papers that talk about hardening strategies around M365. You want to learn more about AAD internals, I definitely check that out. And then Microsoft had their best practices for monitoring ADFS trust. I included that there. The bar at the bottom is a number of different resources I had open as I kind of get digging through this to learn more and more about it. So I didn't have enough room to put all of those different things out there. I know I'm almost out of time. I don't know if there's time for one question or not, but I'm happy to take any questions. I'm happy to chat about any of this afterwards. I feel like every time I do this, I learn a little bit more as I keep kind of expanding this attack, and I'll probably keep playing around with it. But with that, you can find me on those socials, and thank you for your time.